question 6. So, without using a calculator, find the exact value of this squared. So, this is just a bracket to be squared, so it's just a bracket times a bracket. So set it up as so, and just do your usual FOIL, so multiply everything by everything, and rearranging it, you get this. So our first two terms are sin squared 22.5 plus cos squared 22.5, which of course is 1, just from the C2 formula that sin squared theta plus cos squared theta equals 1. Now, with our 2 sin 22.5 cos 22.5, we have to use the double angle formula, sin 2a equals 2 sin a cos a. Now, this is not given, but you can easily derive it from this trig identity, which is given. If we just consider b to be the same as a, we've got sin a plus a, which is sin 2a, equaling sin a cos a, plus another sin a cos a, so 2 lots of sin a cos a. So this does not have to be learnt, but it has to be derived, okay, from what is given. So bearing that in mind, where we've got 2 sin 22.5 cos 22.5, effectively 22.5 is our a, so that is the same thing as sin and twice the angle, sin 45. Now, what is sin 45? We just go to our basic isosceles triangle, where we have isosceles right angle triangle, where we have a base and height of 1, and obviously using Pythagoras, our hypotenuse is root 2. So we can see that sin 45 opposite over hypotenuse is 1 over root 2. So that is the exact value as required. Now, for part 2, we've been asked to show that this can be written in this format. So starting off with this, the key fact is that we can replace cos 2 theta with 1 minus 2 sin squared theta. Now, how we did that, how we knew that they were the equivalent, I've done over here in this pink rectangle. So first things first, you need to be able to establish the double angle formula for cos. Again, just like the one for sin, it's not given, but you can derive it from what is given, this one. So again, let's just let b equal a. So cos a plus a, so cos 2a equals cos a, which is cos squared a, minus sin a, sin b, which is sin squared a. So that is a rearrangement of the how we can work out the double angle formula. However, that's not quite how we want it. We want it to be in terms of sin squareds. So what we do, we then combine this with our C2 trig identity, that cos squared theta plus sin squared theta equals 1. Rearranging this, we get cos squared theta equals 1 minus sin squared theta. So replacing this with this, we get cos 2a being 1 minus sin squared a minus sin squared a, so equaling 1 minus 2 lots of sin squared a. So that is what I'm substituting in over here, and then it's fairly straightforward. We've still got our plus sin theta equaling 1. The 1's cancel, and we've got minus 2 sin squared theta plus sin theta equals 0. Just multiplying through by minus 1, we therefore get 2 sin squared theta minus sin theta equals 0 as required, and we've worked out k to be 2. Now for part B, they're asking us to solve this equaling 1. Okay, so that is obviously the same thing as this. So in other words, we can solve this between the range of 0 and 360. So we start off by, and remember we've worked out that k is 2. So we're actually going to be solving 2 sin squared theta minus sin theta equals 0. So we start off by factorising, giving us sin theta bracket 2 sin theta minus 1 equals 0. So how do we make this 0? Either sin theta equals 0 or 2 sin theta minus 1 equals 0, meaning that sin theta must be a half. Now, within our range of 0 to 360, so including 0, excluding 360, our solutions are sin as theta equals 0. Okay, so we've got a solution of 0, and just thinking of the sin curve, we've also got the solution of 180. So 0 is included, so we've got solutions of 0 and 180. Moving over to the solutions we get from sin theta being a half, By using our calculator, we get our first value of 30. Using our all silver toy cars, we get our second value, remember sin is positive, of 150, being 180 take away 30. So we've got the two values of 30 and 150. So our total solutions are our 0, 180, 30 and 150. Putting them in numerical order, these are our four solutions.